Hello students, hello everyone. So today in the fourth unit, one more main topic, that's an error control. So till now we have gone through with an error detection and there's an error correction. We have gone through with this. Okay. So and now there's a data flow control also we have gone, and there's a last previous sessions and there's a previous classes, right? So now we are going through with an error control. So till now we have corrected on the detector. So we need to control the errors also, right? Whenever it was occurred. So now we'll see this. What are the error controls? Okay. So coming to this error controls, it was occurred offers there's a mechanisms to detect and there's a correct errors. It was refers to mechanisms to detect and correct the errors that occurs in the transmission of frames. Okay, so there are possibility of two types of errors. One is a lost frame, another one is a damaged frame. So already we have seen these two statements, and these two statements we have already heard in the previous classes. Okay, that's a lost frame and there's a damaged frame. Coming to this lost frames, a frame needs to arise at other side. It's going to be fails at other side. Coming to this damaged frame does not arise, but some of the data frame does arise. Okay, it was arrived, but some of the bits are in error, but have been altered during the transmission. There may be a done alteration during the transmissions. Okay, that's an error control. Okay, so let us see this. What are the common techniques we will be using on the error control? So coming to this common techniques of the error control based on some or all of the following ingredients. It may be some ingredients or all of the ingredients. So let us see this. What are the ingredients we are taking here? So first ingredient is an error detection. Okay, error detection. We already have an aware of this. The detecting whether there is a corrected bit in a frame or not. Right? So coming to this second one. So is this the second ingredient? Is a positive acknowledgement. Positive acknowledgement. The destination returns a positive acknowledgement to the receiver that is unsuccessfully received. Okay. The destination returns a positive acknowledgement to the successfully received error-free frames to the receiver, sender. Okay, so coming to the third one, retransmission after timeout. Retransmission after there's a timeout. If the time is already done, afterwards you are starting there's a retransmitting as a data means it will be an issue. So what is this issue? The source retransmits a frame that have not been acknowledged after this predetermined amount of time. Okay, so negative acknowledgement and retransmission. Coming to this statement, this ingredient, the destination returns a negative acknowledgement to the frames when it was transmitted. That the transmission, the error is going to be detected. The source retransmits such frames. Okay, the source it's going to be retransmits that type of frames. Okay, so this is the one some uh, ingredients which we are using on error control common techniques. It may be any one or some of them are is going to be used, or all the ingredients it may be used. One is error detection, one is an error detection, positive acknowledgement, retransmission after timeout, or negative acknowledgement and there's a retransmission. Okay, so these are the common techniques we are going to be used inside this. Okay, so and along with this common ingredients, so we have one more main points here. We have this three error control techniques also. These are the common techniques we are using. So we have some more techniques also. So what are those techniques? That's in three versions of ARQ technique. Already we have heard this ARQ. ARQ is nothing but an ARQ is nothing but an auto repeat ARK is nothing but an there are three types of error control techniques. That's an ARK will save us. That's an auto request query. So we'll see this. What is this ARK? So there's a stop and wait ARQ. There's a go back on ARQ. And there's a selective reject ARQ. So these are the three versions of error control techniques. So we'll see this. What are this? The full-fledged explanation of the stop and wait, go back and selective reject ARQs. Okay, so there's the first one. It's in stop and wait ARQ. So let us go through within stop and wait ARQ. Stop and wait ARQ. There's a stop and wait ARQ is nothing but then first we need to send as a frame 0 and we need to wait for this acknowledgement of this one. So after then we need to send as a frame 1 and after then the acknowledgement. Unless when you are sending as a frame again, so it may be going to be frame lost and A is going to be retransmitting it. Okay, it means this there's a frame 0 is a lost this particular data and it is going to be retransmitting again. Here there's a timeout is going to be mentioned. Again it was retransmitting. Acknowledgement frame 1 and does acknowledgement have an issue now? In the timeout, the acknowledgement lost in retransmission. Again this the B is going to be retransmit again. Again there's a has to transmit as a frame and again there's a B has to dispute as a frame. Duplicate that particular frame. Okay, we have to stop and wait for your repeat format. Okay, so coming to the next one, it is going to be stop and wait is based on the stop and wait control technique. It's a stop and wait control technique. Okay, so these are the two formats we have. Okay, fine. So let us go to this next one. Let us go through with the next one. This is what are the statements I have given. It was mentioned here. So we'll go through with this next slide. This is the station of the frame. So how this acknowledgement is going to be stated. So here we have some problems. So to avoid these type of problems, to avoid this type of problems, there's a frame is or have an alternate labels within zeros and ones. It has an alternate labels within zeros and ones. Okay, so let us see those one zeros and ones now. Okay, here the positive acknowledgement or is the first one to avoid it. So we have an alternative labels within zeros and ones. The first reason, the positive acknowledgements are a form of positive acknowledgement is an have an acknowledgement thus with 0. Okay, here there's a acknowledgement of 0 means it acknowledges the receipt of a frame number 1 and indicates the receiver is ready for the frame number 0. Okay, it's going to be received or is going to be ready for the number 0. And the acknowledgement 1 is an acknowledgement response for your frame number 0 and indicates the receiver is ready for the frame number 1. Frame number 1. Okay, this is the number 0 that indicates us the number 0. So this is the problem. One of the problem. Processing. this data is going to be transmitted. So here you can see this, the first one here, the sender is sending as a frame to receiver, the receiver has sent as acknowledgement to the sender. The receiver will send the acknowledgement to the sender. There may be an between there's a time slot. It may be a time out. Okay. So in the same way, coming to this B, the second one, there's a B. Here the sender, when he has sent the message, there's a frame. The frame was lost here. Okay. The sender is going to be waiting. The sender is going to be waiting. Sender is going to be waiting for the receiver's acknowledgement. Here there's a waiting time was lost. Again the sender will send the frame and it is sending the acknowledgement. When they are sending this request and there's a getting the request from the receiver, there will be also some timeout. Okay, wasting of the time. In the same way, the sender has sent a frame to the receiver. The receiver has the acknowledgement was failed from the receiver side. Okay, so again the sender has to resend a frame, retransmit a frame to the receiver, and he has to wait up to the receiver will send the request. That's acknowledgement, not a request, acknowledgement. Okay, so again it has sent and he has to wait. Here is a timer, right? So in the same way, one more point here, it's going to be taken. Sender will sending us a frame to the receiver and it sends us acknowledgement. Okay. Before receiving this acknowledgement itself, the sender is going to be sends us another frame. So here what happens? The sender is going to be wait for the acknowledgement of the first frame which we have sent to the receiver, and before getting this acknowledgement itself, the sender is going to be sending us a second request, okay, to the receiver. Okay, there may be a timeout while we are waiting for the acknowledgement. Okay, while we are waiting for the acknowledgement. Okay, so this is a stop and wait ARQ. Okay, so here when it is does not arrive after a certain period of time, the sender timeout and retransmits is the virginal frame. Okay, virginal frame. Here there's a stop and wait ARQ has an one technique. So what is this mean? So we'll see. Here you can see this. If acknowledgement does not arrive after a certain period of time, the sender timeouts and there's a retransfer is a virginal frame again. Okay, and along with there's a stop and wait ARQ, stop and wait plus timeout timer, and there's a sequence number also we have to remember. Sequence number also we have to be remember. Okay, so this is your stop and wait ARQ. So we have to stop and wait and we have to time out the timer and there's a sequence numbers. Okay, so what is the main advantage here? Simplicity. We are going to be transmitting and we are getting acknowledgement. We are transmitting acknowledgement. We are getting. Okay, that's it. It's a simplicity. So coming to this, a disadvantage. Only one frame is sent at a time. That is the main disadvantage. And another disadvantage is a no pipelining, and efficiency is very less here. Why? Because it has to wait up to the receiver acknowledgement. When it is waiting also, the time may be accurately it's going to be increases. Okay, so this is the small stop and wait ARQ. Okay, stop and wait ARQ. So now come to the second one, that's it. Go back NRQ. Go back NRQ. Okay, so coming to the go back NRQ concept. So here it is used the concept of protocol pipeline. Okay, that means the sender can send multiple frames before receiving the acknowledgement for the first frame. without receiving the acknowledgement for the first frame. And that is a finite number of frames. There are finite number of frames, that frames numbered in a sequential manner. The frames which you are sending, that may be numbered in a sequential format. Okay, and also the number of frames that can be sent depending on the window size of the sender. It will be depending on the window size of the sender. And the acknowledgement of the frames is also not received within an agreed upon into a period. Agreed upon into a period. All frames in a current window are transmitted. All windows which are currently are transmitted here. Okay, so go back and come back. So it's going to be transmitted. So let us see this, the one workflow of it. Here, the size of sender window determines as a sequence number of outbounded frames. Sequence number of outbounded frames. Okay, so let us see with a small example. You'll get a clear clarity about this. Go back and IARQ. Okay, it's going to be used as protocol pipeline. Okay, so here we're taking one example, that's on 10 window sliding numbers. Okay, so here there's a window size is 4. My window size is 4. The sender will send us a 0 to the receiver. Okay, 0 to the receiver. So the receiver has sends from 0, 1, 2, 1, 3. The sender will send from 0, 1, 2, 1, 3. Why? Because the window size is 4. Okay, 4 sliding windows are transferred. Okay, so the receiver has sends only an acknowledgement of receivers, only in one bit. That's a 0. Okay, if he sends us acknowledgement back, the fourth window is going to be shared as a data. Okay, now the sliding window has moved to from 1 to 4. 1 to 4. The sliding window has moved to 1 to 4. So in the same way, again, the 1 is going to be transmitted. Again, there's a 5 is going to be transmitted from sender to receiver. The 5 is going to be transmitted from sender to receiver. So my sliding window has moved forward. It will be starts from 2 to 3 and 4 and 5. Okay. In the same way, there's the next one. 5. 5 as sent. So next, I did not receive the acknowledgement of 2 and 3. I did not receive the acknowledgement of 2 and 3. So now what happens when it is going to be transmitted? When it is not happens, so we have to wait. So the acknowledgement is not received in time. So the sender was time out to be send this particular acknowledgement. So what happens? It's going to be stopped here. There's a window, sliding window. Okay. So again, it's go back to 2 again. And it is again, it's go back to 2. 2, 3, 4 and 5. Go back to 2. The window will be start sending the message from resending the frame of 2, 3, 4 and 5. Okay. So again, it has to get this. Go back this a frames. So here you can see there's a framing format. So I'll be showing this one more frame. Frame 0, frame 1, frame 2, frame 3, frame 4 is going to be mentioned. Okay, here it is clear. Here you'll get a clarity of it. Okay, again it has to be sends us a messages. Okay, so is it clear of this? Go back to N. There's a node. Again, go back to the node, which is not repeated. If this is a go back N ARQ, automatic repeat request. Okay, fine. So now let us go to this selective reject. This selective reject is an enormous, erroneous, or in lost frames are retransmitted. Here, it's going to be lost frames are retransmitted. Okay, so let us see this, the frames. It is going to be mentioned errors or a lost frames are retransmitted while the correcting the frames are received and buffered. While the correct frames are received and buffered. The receiver, while keep tracking of sequence numbers, buffers frames in a memory and sends NAC for only a frame which is missing or damaged. And the sender will send retransmit packets for which NAC is received. So let us see this now in the diagrammatic representation of this sending. There's a selective reject ARQ. This is a selective reject ERQ. That's it. Here it's going to send this frame 0, frame 1, frame 2, frame 3 to it. So when you are sending those frames, four transmitted we have shared, frame 0, 1, 2, and 3. Okay. So the receiver is going to be sending the receiver's request to 2. He sends the receiver request to 2. And also he sends us the request for receiver to the 4. Okay, why? Because this 4 is not transmitted. Again, it's going to be shared 4, 5, 6. Again, it's going to be retransmitted as a 4. Okay, selective request here, it's going to be shows this selective request ARQ FZ frame junction. Okay, again it was retransmitting, buffering received by the receiver. Again it was retransmitting. Okay, frame 7 and there's a retransmit. Here 4 retransmitted will be done in your selective and reject. There's a ARQ which you want to select to transmit from A to B, and you can reject this particular request or a frame to stop this acknowledgement. This is called as a selective reject ARQ. Okay, this is a small example for your selective reject in LRQ. Okay, see. Okay, it is also works in the form of a sliding window. Okay, fine. Okay, so this is a sliding window request. Fine. So I hope this topics are clear. Okay, so please go through with each and every topic once again. Fine. So if you have any doubt, so please let me know. I'll be fully explaining this a particular topic. Okay. Thank you so much. So please go through with us each and every topic to understand this clear cut. Okay. Thank you so much. So please go through with the topic. All the best. Bye.